supposed to go forever.
Since when did you write in another language?
Changing.
Oh, this is starting to make me mad now. It better go on forever now. That's 3. That's 4.
So we're going to count to forever.
That's 5. So now it's going forever. Ha ha!
7.
Ha ha! I'm the smartest man in the world.
Well, you don't know if that's forever. You got to keep counting.
Yeah, I was going to say we got to count to forever. To
All right. So as you can see, not only did I get all funky with the changing of the colors, but then I'm changing the way that it's going too. Math humor.
So that's why I was evil laugh.
Just because you're changing the color.
Because we're in math class and I made you laugh.
That's
You're laughing right now. Boom! There you go, math humor.
You did an evil laugh.
Knock knock.
Who's there?
Spell.
Spell who?
WHO.
I like that one.
That's English though.
That was all right.
Yeah, ha 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 ha. Come on, Izzy. It doesn't get much better than that. So, what we're going to do today is we are going to, by the end of the week, okay, so we got 4 days, okay, plus we might take a quiz on Thursday. You never know. Haven't decided yet. Maybe, maybe not.
When you say quiz, does that mean formative?
No, when I say quiz, that means summative. Grade
So-
booster.
If we don't do the form or summative, does that mean we're gonna have a formative?
That would be the general rule, yes. I haven't decided yet if we're gonna see how far we get this week, if we're gonna have a formative or a summative.
Okay.
Yeah. Okay. So the ideal, what I want to get to this week is I want us to be able to look at an equation and say, by God, that is a circle, or this is an ellipse because of this, and this. Okay? So, baby stepping it, we're going to start slow. Okay? So, these are all in your notes. This is what we've done the last 4 weeks. We started a month ago with parabolas. Okay? Yeah. And then we did circles.
Just think, 2 weeks ago it snowed.
Okay? And then we did ellipses. And then last week we did hyperbolas. Okay? Alright? So now what's going to happen is, and I'm going to skip this next slide, and I'm going to come back to it, is I'm going to say, here is, don't write this down. Don't write this down. Don't write this down. Here is an equation. What is it? Okay? Okay? And so you're going to be able to say, hopefully within the next 20 minutes, you're going to, actually hopefully within the next 5, you're going to say, okay, this is a blank. Here's why. This is a blank. Here's why. Okay? Alright? So, okay, how to differentiate betwixt the 4 different conics. Okay? Are you ready?
Yeah.
Yeah. Alright. So, what do you think the easiest of the 4 conics is to identify? Why is a parabola the easiest one to identify?
It's the first one that we started with. There's only one shape. Like it's just the function.
But I'm not looking at the
It's a
shape.
function.
I'm looking at the equation.
It's a function.
What do you got, Freddie?
Because it would be like x minus h squared equals, and then everything on the outside.
Even easier because we're not gonna because remember they're gonna look like this. You know what I mean? They're not gonna be in standard form. So that we got to come up with an even easier way to identify what a parabola is because it's the easiest of them. What do you got this time?
It's a function.
Done with you. Say it loud. How many squared terms are there? There's only one squared term in a parabola. It's the only one that only has one squared term. if you're looking at your equation and you only see x squared, nothing else, or no other squared term, or if you only see y squared and no x squared, that's a parabola. And then tomorrow we'll figure out how to put it in that standard form that Freddie was talking about. But a parabola is the easy one to determine, to visually see. Why? Because there's only one square term. Okay? What do you think the next easiest one is? No. No. A hyperbola. Why is a hyperbola the next easiest one? There's actually in all of the other three, there's two squared terms. It's a square minus a square. It's the only one where the squared terms are being subtracted. So a parabola is easy because there's only one squared term. A hyperbola is easy because the two squared terms are being subtracted. Either y squared minus x squared or x squared minus y squared. Now, that leaves circles and ellipses. Both have a squared term. Both have an addition sign between them. Okay? So what you have to look at on an ellipse, on the difference between an ellipse, come on now. There it is. On the difference between a circle and an ellipse is this part down here. An ellipse, the coefficients of the squared terms are different. If it's a circle, the coefficients of the squared terms are identical. Okay? So that is how you determine between them. So what you're first looking for is, you're looking for the number of squared terms. If there's only one, it's a parabola. Okay? If there's two, it's a hyperbola, a circle, or an ellipse. If what's in between them is a subtraction sign, it's a hyperbola. If the numbers in front of them are different, it's an ellipse. Otherwise, it's a circle. So my question to you now is, what is what of those four? Identify, classify each conic section. What do you got, Jacob? Why is A a hyperbola? Because the squared terms are being subtracted. So there's two squared terms, is what you're telling me. Okay? So my first look here is at the fact that there are two. Whoa. Is that there is a squared term there and a squared term there, right? Okay? And then more importantly, your next look is that there is a subtraction sign between them, so this one is a hyperbola. I would agree. Identify me another one. A. Why is B an ellipse? So first off, there's a two squared terms. They are being separated by an addition sign. And then, because the coefficients are different, you said ellipse. I would concur with all of that logic. me another one. NASCAR.
C is a parabola.
Why is C a parabola?
Y is squared, X is net.
Only one squared term. And that's it. Someone identify for me the next one. I know, but you three always answer. That's why I don't want to call in. I'm waiting for give somebody else a chance. Krabs, what do you think? Well, what should we look at first? Why? Okay. All right.
Process of
Okay.
elimination.
Process of elimination. Okay. Can you give me a little more justification?
Not really.
Well, how many squared terms are there? 2. Okay, so that means for sure that it's not a parabola, right? Right?
Yeah.
Because parabolas only have one. Okay. What's the sign in between them? So that rules out hyperbola, right? Okay, so now we're down to circle and ellipse. What do we look at?
Coefficient.
We look at the coefficients. Thanks, Snufflepuff. And since they're the same, it's a circle. I know. You're one of them. Okay? Yeah, because you don't. All you do is yell. No, that's yelling. All right. So to bring you back into speed of getting things into those standard form type stuff, what I would like you to do now is, given those two conditions, write me the equation of that conic section. Okay? Go for it. So, remember that we're talking about a circle here, right? So the equation of a circle is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. Yes, Yes. Okay? So this one, I'm guessing everybody got right away. So this one should be x minus 3, quantity squared, plus y minus negative 2, quantity squared, equals 16. Because I got to square my radius. Yeah? Questions on that one? You good? Okay, because you were giving a look of like, or was that just a, school? Okay. Gosh forbid you yell at me. Parabola, yes? Okay, so, because it said so right here, that it's a parabola, but I can't determine which one it is yet. I've got to look and see first at what I am given. So what I am given is the fact that the vertex is at -2, -4. So my vertex is somewhere down there. Then it says that my focus is at 4, -4. So that would be over there. So which way does my parabola open? It opens to the right. And a right open parabola is of the form y minus k, quantity squared, equals positive 4p times x minus h. Yes? Yes. Okay. Do I know what h and k are? What's h? What's K?
Those numbers.
Those two numbers right there, because H and K come from my vertex. Okay? The only other thing that I need is P. What is P? What? What is the distance from the vertex to the focus? 6. This distance here is P, which is 6. So my parabola is y minus -4 quantity squared equals 4 times 6 is 24 times the quantity x minus -2. Yeah, buddy? Yeah, buddy. I wish to. Try those two now. So, we be talking, this one is an ellipse. Okay? So, an ellipse has one form, x minus h quantity squared all over a squared plus y minus k quantity squared all over b squared equals 1. Right? Okay? Do I know h and k? No. Don't have my center, do I? Okay? Can I find my center, though? How can I find my center? So it's the midpoint of these 2 points, right?
Yeah.
What is that? Three comma 5. If I didn't like those 2 points, what other 2 points could I use? You could use the foci too. Also, the midpoint of those 2 points. 10. So, we've got a vertex here and way over there, a foci here and way over here, and a center right in the middle. Okay? So, this value right here is C, right? So what is that? 2? Yes or no? Distance between the blue point and the foci. 2? 2. Okay. We've got this value right here, which is A, which is how much? 4. Distance between the center and the vertices, since they're horizontal, is A. Can I find B? How can I find B?
Using the equation c squared equals the absolute value of a squared minus b squared.
So C squared would be 4. A squared would be 16. And B squared is B squared. So what is B squared? 16 minus what gets me 4? 12. So my equation here is x minus 3 quantity squared all over 16 plus y minus 5 quantity squared all over 12 equals 1. I am guessing, and I will give you 5 more minutes to do H. I'm guessing you need more time for that one. Got vertices at 7, -3, and 7. I gotta move that down a little bit. And 7, +1. Foci at 7, 4, and 7, -6. Where or which direction does this open? An up-down hyperbola is y minus k, quantity squared, all over b squared, minus x minus h, quantity squared, all over a squared, equals 1. Where is my center? What do you got? 7, -1. Do we concur? Midpoint of these 2 points, or the midpoint of these 2 points, with my center there. This would be my B value, which is how much? 2. This would be my C value, which is 5. C squared is going to equal A squared plus B squared. So 25 is going to equal A squared plus 4. 21 is A squared. Agree? I don't know. Yeah. It's coming from the air. It smells like, no. It smells like somebody dropped a cow pie. Because it smells like manure. Yeah. Okay? So y minus -1, quantity squared, all over 4, minus x minus 7, quantity squared, all over 21, equals 1. Agree? Okay? Oh, snap!
So we are going to do this Wednesday.
What does it say? On the board in writing already.
No, that's weird font. I can't read it.
I understand.
Wednesday. Scroll backwards.
We can have it due in 4 minutes.
I'll do it tomorrow.
Is it doable in 4 minutes?
What is that? 4 problems?
Just so you know, before I forget, you should try and find your textbook.
Well, I know mine's on my dresser at home.
Because in a week, I'm going to have those, you turn those in. Otherwise, it's $55 and you don't get your diploma in less than a month.
Okay, we have it.